you can see my screen, you'll see the number 5 circled.
I can see it.
Cosine 157.5. Like we've been talking about, you have to double this number, and that could be easy or hard. Don't know if you got a calculator or not, but it's 315 over 2. And the reason is that that formula we keep grabbing, it doesn't use the number you're given, it uses double that number. So you have to be able to work with that doubled value. So I'm going to snip the formula right below it here again. The formula here. So your problem here is plus or minus square root 1 plus cosine 315 over 2. So again, you get your unit circle. Where's 315? It's right over here between 270 and 360. It's right in the middle. All students take calculus. We'll write that down as well. So the x value there on the unit circle is 2 over 2. And plus or minus. Okay. So now just a matter of simplifying this thing. We talked at length about how you decide about this one. It comes down to the original problem. The original problem is 157.5. Well, where is that? 0, 90, 180. Cosine is the 157.5 is in the second quadrant, and we know that it's negative. They seem to all be negative, which may or may not be the case on the exam. And then this reduces to 2 plus square root of 2 over 2. It's just like the previous ones that we have done for that.
All right.
All right. So now we're on to, I don't want to go that one. I'm going to go to the last one here, number 6.
We can cherry pick these ones if we want.
Oh, yeah. Are you sure? So we got 6 was the next one up. You tell me where to go then. You want to go to 7?
Yeah, let's go.
All right, we'll go to 7. So this is what I wanted to find. I wanted to be able to snip this in because these problems are covered. These are the kinds of problems you might see on a placement test at a university. All right, so it says tangent of theta equals 15 over 8, where 180 less than theta 70. So this is telling you that you're in quadrant 3. And I've mentioned, I call it the reference bow tie. There's the angles that you get. 3, we want that one. So we want that one down here in quadrant 3. This is your triangle. This is your theta. So tangent theta. So the tangent is y over x, or opposite over adjacent. So that's 15 over 8. But you should say to yourself, well, that's not right because I'm going left. So that's negative. And going down, that's negative. Okay, that's how it reduces. You almost always find the third side. This is a Pythagorean triple 8, 15, 17. There is that value. Okay, we haven't even gotten to the question, but there's all that set up here. Tangent of 2 theta. You're going back to your trig sheet, cheat sheet. You're going to a different place altogether. You're going to the double angle formulas on page 2, double angle formulas. And you'll see there's 3 of them. Again, one for sine, one for cosine, one for tangent. And it could be a little bit confusing because of what we just did. So you are finding you're finding the tangent of 2 theta. So the tangent of 2 theta is 2 tangent theta over 1 minus tangent squared theta. And so you have those values. This is 2 times the tangent of theta is 15 over 8. The tangent squared of theta, well, you take that number we just found and you square it on the bottom here. So this becomes, and this is where you just have to get good at simplifying. This becomes, it's better to divide first. So it's 15 over 4 over, and this is 1 minus 225 over 64. So this is like 64 over 64 minus 225 over 64. And if you have a calculator, definitely grab it at this point and just simplify this here. This is what is this? 161 minus 161 over 64. The top one you can turn into an over 64 if you multiply the top and bottom by 8. So you end up getting 120 over, I'm sorry, multiplying by 16. My mistake there. So that's 240 over 16 or minus 161 over 64. So that's 64 there. And then you end up getting 240 over 161 negative there. That's your final answer here. I probably should check that. Yeah, and that is right. It's let me send this to you in the chat because that may be what you want here is the answers more than anything, in case you don't get through everything. So let me get back to that. I find the chat is hard to find in once we're sort of recording here. Come on, chat. Okay. There it is. Okay. All right. So that's what we're working on, and we'll jump to the next one here. If you're talking, I'm not hearing you. Maybe you're muted, and that's okay. But just check in with me if we're not covering something that you want to cover.
No, we're covering everything that I want to cover.
All right. So we're up to number. We should do 8 because we just did 9 is kind of like 8, or kind of like 7. So should we do 8? Because we want to do a tangent, and then we should probably do. I'll give you. Okay. Unless I hear others, I'm going to do 8 next.
Sounds good.
All right. So this again, you got to figure out which quadrant you're in. You're in the second quadrant, and if you look up in that picture, you'll see that the reference triangle looks like that. That's theta. Cosine theta is adjacent over hypotenuse. So if we assume that the 9 is the hypotenuse, does it make sense that minus 2 squared of 14? Well, it does, because you're going left, so that's where you get the negative, and then we got to find this other side here, maybe. Okay, I usually suggest finding it, so we'll call it b. So we have minus 2 squared 14 squared plus b squared equals 9 squared. So when you square that, that becomes 4 times 14. It's 96. I'm sorry. 4 times 14 is 56. 56 plus b squared equals 81. Subtract both sides, so b squared equals 25. So b equals 5. So that's 5. That works out nicely. Okay. Now you need a double angle formula for sine. So we go. This one actually illustrates what I was hoping to see in the first problem we did, which is that you do actually have to solve the triangle. You may have said to yourself, well, I didn't need to solve the triangle for the last one because it was just given. Here we need both the sine and the cosine of theta, meaning you need the opposite side so you can get the sine, because the sine of theta here is 5 over 9. It's opposite over hypotenuse. Cosine of theta, well, we have that from the given. We could also get it from the triangle there. So that's what it's asking for sine of 2 theta. We've got the formula here. So this is minus 10 square root 14 over 81.
All right. That's understandable.
So I assume there's we're just gonna keep going here, so we'll do that. I said let's do 8, 9, but not, or 8, 7, 8. We can do 12. 12 is like 7. I guess we can do. We haven't done a cosine of 2 theta. Okay, we can do 10 next.
All right, let's go on.
All right, so you're in the first quadrant. That's what this tells me. And the triangle in the first quadrant looks like one that we're used to seeing. So the theta here is opposite over adjacent, so square root of 3 over 3. Can you find that hypotenuse for me? Can you tell me what that value is?
Hypotenuse here?
Yes.
Is it 12 squared?
So it's a squared, 3 squared plus the square root of 3 squared equals c
9
squared.
plus 3 equals 12. And then square that up, 144.
Well, you undo a square with a square root, so you gotta get smaller. So the
Oh,
square root of
okay.
12 equals c. So that's 2 square root 3.
Oh, I see what you mean.
So this is 2 square root 3. Now I don't know if we need this, but we're trying to find cosine 2 theta. So cosine 2 theta is again another cheat sheet reference here. This one though is interesting. It's got 3 variations on it, and if I were a student again, I'd be like, why are there 3, or which one do I use? Probably what I would care about. And the answer is you use the one that's most convenient. Meaning, like, well, what do you have? And um, like let's just say it gave you cosine of theta. You'd want to use this middle one because it's already a cosine. Let's say it gave you sine of theta. You'd want to use this last one. Since we don't have either, we might as well just use the first one for this one. So what is the cosine of theta according to this picture? Well, it's the adjacent over the hypotenuse. What is the sine of theta? It is the opposite over the hypotenuse. Okay, so these actually reduce. This I'm actually surprised this one reduces so nicely. Did we even do that right? 3, 9, 3. Okay, that's just a weird triangle. Okay, so we're just going to plug these numbers in. So it's 3 over 2 square root of 3 squared minus, not plus, minus square root of 3 over 2 square root of 3 squared. And we just got to do some manipulation here. So the top is 9, the bottom is double 4 times 3 is 12, minus top is 3 this time, and the bottom is 12 again. So it ends up being 6 over 12, which is 1/2. Um, Up to you if we keep going down this path of doing these. I mean, we do need to move to 13 through whatever, but if you just want to get through this, we can certainly get through all these questions. I would definitely do 9 next because it's a half angle again, if you wanted to do another one.
I'd like to keep going.
You said like move to 13 then, 14,
Yeah.
15? Okay. So 13, this is more of what I was expecting to see from you from your quiz review. It's like let's make the left side looks like the right side, and let's pick one that's a little bit tougher, more challenging here. So this one has got everything in it. It's got a few more things than you're used to seeing. So the top here, we want to make the left side look like the right side. So the top here, this sine 2x, that's an identity, not to be confused with sine squared, but it's sine of 2x. And I'll just snip the formula in here. This is one that most students remember. It's the one that's worth remembering. It's that 2, but that 2 comes out in front. 2 sine x cosine x over cosine x. We're just working on the left side. Those cancel, so you get 2 sine x, and you're done because it now looks like the right hand side.
Alrighty.
All right. So now let's do 14 because, well, I mean, these are all a little different. These are like, um, 14 actually isn't very good to do because it's just undoing what we just did. 15, we'll do 15 next. I can come back to 14 if you want. All right, so 2 sine x cosine x over cosecant squared x minus 1. All of that is supposed to equal tangent squared x sine 2x. So to me, the left side is more complicated. And when I look at that numerator, that is the sine of 2x. That is 2 sine x cosine x. So that's sine of 2x up top. And that's good because I see there's a sine of 2x in the answer. So I'm feeling really good about that. Now on the bottom here, I don't feel so good about the bottom. But when I see a square, that's where you go, okay, squares are identities, Pythagorean identities. So let me snip the identity that has cosecant squared in it. So here's the identity for cosecant squared. And you might say to yourself, well, this one doesn't work because I've got cosecant squared x minus 1. Can you make this look like cosecant squared x minus 1? Well, yeah, you can subtract 1 from both sides. So cotangent squared theta is cosecant squared theta minus 1. And that's what this is. This on the bottom is cosecant squared minus 1. So instead of writing cosecant squared x minus 1, we're going to write cotangent squared x on the bottom. So we're substituting in cotangent squared x for this cosecant squared x minus 1. And I feel real good because we're closer to tangent squared than before. So now it's like, well, we're kind of there. So now I have to remember, okay, tangent squared x is 1 over cotangent squared x. So this right here can be broken into 1 over cotangent squared x times the sine of 2x. And if we say, oh, well, this part on the left is really tangent squared x times sine 2x, we are done because that is what we were looking for from the beginning.
Perfect. Let's move on to the next one.
Running out of problems here. 16 is the last one. So this one, well, they do choose a fairly complicated one here. This is a great example of you really only have one side to work on. It's like the left side is way more complicated than the right side. So hopefully we can get something out of that. One of the things I see right away is that there's really like a 1 over cotangent squared x. And that part right there, that 1 over cotangent squared, we just did that in the previous problem. That's tangent squared x times sine 2x over 1 plus cosine 2x. Okay, so we're good. Then we want that because we really want to get cubes. So we're hoping this thing right here that I'm circling becomes a tangent x. So now this is where it's like, well, what do we do? Like I've told you many times, you rewrite the top sine 2 sine x cosine x, but sometimes you take steps and you're like, well, maybe that wasn't right. Let's look at the bottom here. 1 plus, okay, there's a lot going on here. Let me grab these. All right, so I'm grabbing some identity, or not identities, I'm grabbing the double angle formulas. So looking at that cosine 2x here, cosine 2x here, and I'm saying, okay, well, like how do I get a 1 plus? Well, there's a plus 1 here, so I'm liking that a lot. Because this minus 1 can come back over. Like each of these is really cosine 2 theta equals that. So you have a cosine 2x. So if we bring this 1 over, 1 plus cosine 2x, like I'm bringing this 1 over, equals 2 cosine squared x. So this right here is this right here on the left. I can replace it with this. So it becomes tangent squared x times sine 2x over 2 cosine squared x. You might think, well, that doesn't really help me all that much. Kind of does though, because we got sine over cosine now, and we're getting closer. And this is where we got to use that first identity. So sine double angle formula. So sine 2x is 2 sine x cosine x. So this top becomes 2 sine x cosine x over 2 cosine squared x. And you'll see that the 2's cancel. That tangent squared comes down. You'll see that this cosine cancels with one of those. So we have tangent squared x times sine x over cosine x. And what is sine x over cosine x? It's tangent. that gets you down to your tangent cubed x, and that's what you were looking for here.
Perfect. I'm gonna go and look for my math book, and I'll be right back. And
Okay, sounds good.
Problem for 9.2.
Okay.
Right back. All right, I got my book. I'm gonna pull out the problems. I'm gonna send you pictures. All right, let's see. Where is it? Which email do you want me to send it to? Do you want the tutoring by Matthew.com or the learning at one? All right, should have sent.
Still not seeing it. I'm checking here pretty regularly. Hopefully,
To the learning at math.matthew.com.
you want to reply to the booking email? Be best. It's
I'm going to do that real quick. Let's get it. Come on. Let me attach these. Hmm. This is kind of being a pain for some reason. Try to send it. That was what I want to send. There we go. Here
Okay, I
we
do
go.
see
Okay.
something's come through here. Got some
That's
picture.
was it a picture or did it just send?
Nothing. Yeah,
Yeah,
nothing attached.
it just re-forwarded the email. That really annoys me. I'm waiting for this first attachment to load up, and then I'll send the second attachment. God, this is very, very slow. Come on. So close for the first one. There, that's the first attachment. Second attachment, gonna take a little bit. All right, it's loading. I'm about to send it. There we go. All right, should be sent.
Okay.
Right about. Come on. Bye now. I want to start with 5 and go through 19 odd.
Okay.
And then 21 through 39 odd. Then 47 through 50. And 53 through 57. We probably won't get to all of them, but I just wanted to get started on this.
Yeah. There it is. Okay. So, all right. Start with number. Yeah. I mean, these are well. There's online calculators for all of these. Like if you got a thing where you got to get these done. I mean, you can get the answers. I know you got some of the answers, but uh, we've done a few of these. So this is a summer difference formula. Pi over 12 is 15 degrees, and we covered this before. Like, well, how do you get 15? Well, it's like 30, 45 and 60. So you have some options, just depends what you like. Let's do 45 minus 15. So sine of 45 minus 15, oops, I'm sorry, minus 30, that gets you to the 15. So this is that sine alpha minus beta that we've been talking about. So I'll snip that in.
Okay.
Grabbing that formula here for you again. If you do enough homework problems, you do actually remember it. Okay, so in your problem, you got your alpha and beta. Your alpha is 45, so this is sine 45, cosine 30, and then it's minus. Minus goes with minus down here. Cosine 45, sine 30. Now you need these values. You have to know these values really well. Let me move this. This is in the way. So sine 45 is square root of 2 over 2. Cosine 30 is square root 3 over 2. You're multiplying those. Minus cosine 45, that's square root of 2 over 2. Sine 30 is 1/2. And these have to have the same bottoms here. So this is the square root of 6 over 4 minus the square root of 2 over 4. So it's the square root of 6 minus the square root of 2 over 4.
And that's, do you just leave it like that?
That is your final answer. Yeah.
Perfect. All right, let's go on to number 7.
Number 7. Jeez. They the way these are organized, this one's very similar to the one we just did. Okay. All right, so minus, this is the equivalent of sine of, sorry, minus 5 pi over 2. This is minus 75 degrees. Yeah, minus 75. This is one that's like, well, what are we going to do here to get this? Well, you can do, yeah, there's a lot of options here. 120, I'm sorry, 45 minus 120 will get you there. And that's the hard part, is figuring out, well, which ones work here. And this one does. So this is really the sine of 45 minus 120. Now there's a lot of options. Like you could do minus 30 minus 45. I generally stay away from the negatives on the front. But that's another thing here. And yet another thing you could do is, remember how earlier we said sine of minus x equals minus sine x? You could do that as well. But let's just do this one because we've already got the formula and we've done a couple of these like this. So let me grab the formula up here. So again, your alpha is 45, your beta is 120. So this is sine 45 cosine 120 plus cosine 45 sine 120. And if you got your unit circle, I mean, it's really handy. We're kind of right there on the unit circle. So sine 45, that's square root of 2 over 2. Cosine of 120 is minus 1/2. Cosine 45 square root of 2 over 2. Sine 120 is square root of 3 over 2. So that's minus square root of 2 over 4 plus square root of 6 over 4. You do combine them. I'm going to put the square root of 6 first. Square root of 6 minus square root of 2, that's the top, over 4. That's your final answer on those.
All
I
right.
don't normally do these in degrees, but I'm seeing with you that it's just the clarity it's probably a lot more clear rather than having pi's all over the place. So this 13 pi over 12, well, what is that? Like, 13 pi over 12. We need to figure out what that is. So how do you convert that to degrees? You multiply by 180 over pi. So can you tell me what 13, what this becomes? You get your calculator handy for that one?
Yeah, I have it out. I'm going to put that in real quick. $195.
So this is 195 degrees. Okay, so how do we get there? We got to add 2 things to get to it. And
That's in the third quadrant, though. That's why I know.
Yep. But we have options like you can go like 45 and 150 because those are on the unit circle.
Yes.
Okay, and those are reasonable values. There's lots of other ones that work. There's 135 and 60. You can choose or whatever you want. Like, it doesn't really matter. But I'm gonna use this first one here. And so this is sine 45 plus 150. And we're just grabbing that relationship sum and difference formula. So your alpha is that, your beta is that. So it's sine 45 cosine 150. The pluses match. This is plus cosine 45 sine 150. And where is 150 degrees in the unit circle? It's right there. It's kind of closer to this way. So that's square root of 2 over 2 is sine 45. Probably getting familiar with some of these. Cosine 150 is minus square root 3 over 2. Cosine 45 is square root 2 over 2. Sine 150 is 1/2. So we get minus square root 6 over 4 plus square root 2 over 4. We end up getting square root 2 minus square root 6 over 4 for this. 11. We'll keep going to 11.
Let's keep going.
All right, so think of two numbers that are nice that add up to 75. So hopefully these are the ones that you came up with, 30 and 45. They have to be on the unit circle. That'd be like values that you know. So this is cosine 30 plus 45. The order doesn't matter here. You could do 45 plus 30. It is a different sum and difference formula though. So we got to grab the other one this time and make sure we have it down. If we're in a classroom, I would make you write this down because you would remember it. And it's part of learning, part of being able to do this. So your alpha this time is 30, your beta is 45. So this is cosine of 30, cosine 45. It's plus here, so then it's minus up here. So this is minus sine 30, sine 45. I'm going to move this down, so kind of in the way. Okay, cosine 30. Cosine 30, that's square root 3 over 2. Cosine 45 is square root 2 over 2. You're multiplying those. Sine 30 is 1/2. Sine 45 is square root of 2 over 2. Square root of 6 over 4 minus square root of 2 over 4. And then you can combine those here into one fraction. Square root of 6 minus square root of 2 over 4.
Yes. Okay.
All right, so that was 11 up to 13. To 13. So notice again, like when it's in degree, if it's not in degrees, you're going to probably convert these to degrees. Hang on just a second, please.
Yep.
All right, so two numbers that add up to 105. When you do a bunch of these, you start seeing the combination really
Oh, I
well.
see what you mean. Okay.
It's got to be numbers that are nice. Now, again, this is from the reference sheet. I don't have any magic here. These aren't. I don't think they're all that memorable. So you just get them down. Get the formula down. Your alpha is 45. Your beta is 60. So it's tangent 45. Plus here goes the plus here because it's on top, plus tangent 60 over 1 minus tangent 45, tangent 60. Okay, so tangent 45, that one's got to be pretty clear. I mean, that's one. That one you got to look up. Now, tangent 60, that's a little hard. So it's sine 60 over cosine 60. So sine 60 is square root 3 over 2. Cosine 60 is 1/2. So this one's not too bad. It becomes square root 3. So this is 1 plus, tangent 45 is 1, square root 3 over 1 minus 1 times square root of 3. And then, depending on your instructor, maybe you can leave it like that. Sometimes they want you to rationalize, but we'll just leave it like that for now. Okay. Most students like going, we got 15 to do. Darn. Okay, we'll do 15.
We cherry pick the last few.
Yeah, let me just go into 17 because these are as frustrating as maybe the previous ones were. These are going backwards, and you're like, oh, this is great. Like, you give me more of these, but you got to know the formula. You got to know what is a cosine, sine, and that is. And I'll snip it in here. It's the cosine alpha plus beta. So let me snip that in here. Get these lined up a little better. So you can see here, that's your alpha, that's your beta. That's your alpha, that's your beta. So this is cosine. Because you have a minus, it's a plus. So it's pi over 3 plus 2 pi over 3. Well, what do those add up to? Well, that's cosine of pi. And that's -1. That's right on the unit circle. So these are way faster because you don't have to write as much. You're condensing. You're not expanding. Expanding is often a lot longer. So let's go to 21. 21 was part of the original list, I think.
Yes.
So I'll do the same thing here. I'm going to grab the formula, the identity, and put it right below this. So you can see. So you can see here, I think, if I line these up, like that's alpha and that's beta. Alpha and beta. Okay. Now, based on these math signs, plus minus, plus on top, minus. So the plus goes with the plus on top. So this is tangent 80 plus 55. And that's the tangent of 135. You're like, well, that doesn't seem right, but that's over here. So there's two values for tangent that you should have figured out when it's on here. At 45 degrees and 225 degrees, do you see how these are on the same line? This has a slope of 1, which is what tangent of 45 is. 135 and 315. Well, this has a slope of -1. So this one equals -1.
Okay, no.
And you'll find that very memorable if you can get kind of that. You got to find some shortcuts here to get through these. Otherwise, you get tired of writing them down over and over again. Oh my gosh. Did you really say 20? Scrolling up here. Which ones did you say? 5 through 9, 21 through 39 odd. Oh boy. They're just very repetitive, and I see if we can cover what we can cover here. Yeah, I guess we'll just do more of these. You just sent, this is the only page you sent. Oh no, you did send another page. Okay. Sorry, I'm having it on. I'm hoping like, oh, maybe there's some short stuff that we can get through that's faster, but nope. All right. Okay, so this is the sum and difference formula for sine. So this is your alpha, this is your beta. So this becomes sine 180 cosine x. And then minus goes with a minus here. I'm just looking at the formula. Cosine 180 sine x. We did this earlier. This was in your review quiz. You got to figure out what that is. On the unit circle, 180 degrees is over here, right there. So what's going on there? Well, it's -1, 0. So the -1, 0, that means that cosine is -1, but the sine is 0. So 0 times cosine x minus x. The left one 0, so this just becomes sine x. Okay, great. 25. We'll do 25. Yes. It's a cosine formula. So at this point, I'm going to read off the formulas. We worked this out. I mean, we've done so many of these that I'm just looking at the formula. This is your alpha. This is your beta. So this is a cosine 180 cosine x. Plus goes to minus in this formula. Sine 180 sine x. So just like the previous problem. Okay, cosine 180, well, that's -1, negative cosine x. Sine 180 is 0. So this becomes negative cosine x. All right, that's 25. 27 is kind of the same. Let's do a 29, I guess, because it's a tangent. We haven't done a tangent yet. All right, so this is your alpha, this is your beta. If you look on that reference cheat sheet, you'll see that it becomes tangent 180, and then these have to match. So it's minus tangent of x over 1 plus tangent 180 tangent of x. So now on the unit circle, again, we're over here, left side, the point minus 1 comma 0. So tangent 180 is y over x, 0 over negative 1. So this is 0, and then this is 0 here. So the top becomes minus tangent x. The bottom becomes 1 plus 0, or just 1, and that reduces to minus tangent x.
Perfect.
You said like, give me the numbers again. You said like 50, 51 part of it?
21 to 39, 47 to 50, 53, 57. All these are odd, I think.
Yeah.
Are there any of them that really stick out to you?
47 has 1, 2, 3, 4, 5, 6 parts to it. These are like massive problems to do. They take a while. I'll start 47. We're not going to finish it, but it's enough that you'll get enough out of this that you can do. You'll get what's important out of these.
Thank you.
So 47, a lot of given information. So cosine A is 3/5, cosine B is 5 over 13. But they tell you here that A is in the first quadrant and so is B. And that's really nice. It's a nice introductory one here. So here's A and here's B. So A is adjacent over hypotenuse, sine is opposite over hypotenuse, and then these are Pythagorean triples, so we're good here. Okay, so that's the given information, and you have to do this for each of these. You have to solve the triangle first. Part A, you'll love part A because you're like this is a really long problem. It wants you to just find the sine of A plus B. And by now you're supposed to be like, oh, I know that. That's a sum and difference formula. So sine is sine cosine. So it becomes sine A cosine B plus cosine A sine B. And you might think, well, I don't have any of this. Well, you do. Sine of A is 4/5. Cosine B, if I come over to B, that's 12 over 13. I'm getting the information from this triangle here. Cosine A is 3 over 5. Okay, got that. Sine of B is 5 over 13. Okay, so for each part of this question, this is 48 over 65 plus 15 over 65 becomes 63 over 65. For each part of this question, B through whatever F, you go back to this triangle and you're going to pull off different values. Like you might find you'll do a double angle and a half angle. And these are 47 is an example of like a test question where it like totally summarizes, do you understand everything that's going on here?
Yes.
So if it was unclear, we can always do it again, but we do have to cut off here for
That's
the
fine.
lesson. So I'll
Thank
send
you
you the
for your
notes
time.
and screen recording out shortly. And thanks again for scheduling.
Thank you very much, Matthew. Have a nice night.
You too. Bye now.
Bye.